Okay, now we look at the rectangular. Rectangular, this is another activity 2 now. The new activity 2, we are having a rectangular area again, which needs to be enclosed with 140 meters of fencing, where one of the sides is an existing wall as shown on the sketch. Can you see now on the sketch, now we have an existing wall there already. So we are going to put a fence around the remaining part, of which this is this U shape here. Why? Because this side we will attach this fence to this particular wall. So no fence on that side, okay? We will take the advantage of the wall and put the fence around the trunk, as shown on the diagram. Now they say determine y. We are given y for the length, and then the breadth is x, since the opposite side of the rectangle are equal, so they are both indicated by y, by x, both of them. And then now they say determine this y side now in terms of x. Grade 12, same method, we use what is given to us. What is given to us is the perimeter, because it's the fence that we are going to use to enclose that area. So now we are going to rely on perimeter. Do you still remember? The perimeter is 2L plus 2B. This is the plus, this is 2L plus 2B. But in this case, are we having 2L and 2B? No, we have only 1L plus the 2B, of which you need to close. Remember, this is our length. We have only one. But breadth, we are having two sides of breadth. Is that side and that other one. So the perimeter formula will be L plus 2B for this, because we will be only fencing 3 sides, okay? So what is the perimeter? 140. Length, or our length is y. That will be y plus 2x. And then now we want y in terms of x. We are going to transpose this to the left-hand side creature. So basically, we will be having our perimeter equal to L plus 2B. And then this is 140 for the perimeter substituted to y plus 2x. And then we transpose 2x to the left-hand side. That will be a 140 minus 2x equal to y there. So that is the y side. So our y is equal to 140 minus 2x in terms of x. Okay, moving on to the next question. A rectangular area, we are still using that 140 meter fencing. Remember, we have just calculated that this length is equal to what? 140 minus 2x, of which is our length. So the breadth is equal to x there. So now the question states that show that the area between the wall and the fence will be given by area into x is equal to minus 2x squared plus 140x. So that means the formula for the area is already given to you. Your answer is given to you. Yours is to show that this is true, grade 12. Okay? Show us, grade 12, is this the correct answer? So now we are looking for the area between the wall and the fence. And then remember, the formula for the area is given to you there as area is length by breadth, because we are looking at the area of the rectangle. And then that is area equal to L times B. So now we are substituting the length with 140 minus 2x and the breadth with x. Hence we have x into 140 minus 2x as our substitution there. And then we are going to multiply x in there. So x times 140 will be 140x. And then the x times minus 2 will be minus 2x squared. So that is the area in terms of x. Okay, can you see that we have 140x there and the minus 2x squared there, great job. So that is the answer for that particular area there, exactly the same as expected. And then with the 2.3, they say a rectangular area, we are still using the same information, given data, and then now we are still having that y side, which is equal to 140 minus 2x, which is our length, and then we have the breadth of which is equal to x. Remember, we have calculated the formula of area on the previous question in terms of x. In this case, now we need to determine the value of x that will result in a maximum area enclosed between the wall and the fence. The value of x of which the area is maximum. What does it mean? This statement here, maximum area, it is telling you what that derive the area. Okay, differentiate the area in terms of x and solve for x. That is the method throughout grade 12. And then that means we are going to take our area equal to 140x minus 2x squared from the previous question. And then to maximize the area, we are going to derive the area in terms of x. So the derivative will be now, if it is x to the power 1, our derivative will be 140 as indicated there. And then for the next term, there is 2 times minus 2, which will be minus 4. And then from the exponent, we subtract 1, it will be x to the power 1. Therefore, this is the differentiated equation of our area in terms of x. And then do you still remember grade 12, after differentiating, what must you do? You let your derivative be equals to 0. So the next step now, we will be taking this derivative and equalizing it to 0. And then after equalizing to 0, you now do what? You solve for x. So we are going to take minus 4 to the left-hand side. It will change and be 4x after transposing. So this will give us 4x equals to 140. And then we divide both sides by 4 because we need the value of x. And then when you divide 4x by x, it will give you x. And then 140 divided by 4 is 35. And then this will be in meters because now the fence is given in meters there. So that means now the value of x will be equal to 35 meters. So basically that means the breadth side here is 35 meters. Okay, if you want to calculate the length, then it will be 140 minus 2x, of which it will be 140 minus 2 into 35, grade 12, it will be 140 minus 35 times 2 is 70, and then now that means it will be equal to 70 there. So now this simply means now the length of this, of which is y, it will be equal to 70. Okay. Can you see this one is a rectangular one? Because the length is not equal to the breadth. Breadth is 35, whereas the length is 70 there. Still on question 2. A rectangular area, we are still using the same information now. That this will be 140 minus 2x as we have indicated, and then this is our breadth x, and then this is our length y. And then determine the maximum possible area. Maximum possible area. That means we are going to now take the value of x that we have calculated. We have calculated on 2.3. After maximizing area, we find the value of x being 35. Now we want to calculate the maximum possible area that will be enclosed by this fence. So now that means we'll take the original area formula, of which is 140x minus 2x squared, as we have calculated previously. And then we are now going to substitute that value of x that we have calculated has been 35 on the previous solution and substitute for x here. Where we have an x, we are going to remove and put in the 35. So now into your calculator, grade 12, straight to the answer. And then this will take us to the answer that is giving us an area of 2,450 square meters. Or alternatively, grade 12, you can take length by breadth, of which will be the 35 times the 75 of your length there. And then this is 2450 square meters. It will give you exactly the same answer there. And then now, grade 12, I want you to try this one on your own. I am giving you 5 minutes. We have a cereal box that has the shape of a rectangular prism, and the box has a volume of 540 centimeters. That is the volume. And then the breadth of 4 centimeters, the length of x centimeters, as indicated on the diagram there. And then now determine the height of the cereal box in terms of x, grade 12. And then your 5 minutes start now. You have your formulae inside the box there. Our 5 minutes start now. Please try that one on your own. Okay, grade 12, let's see how far did you go with this particular problem. Remember to send your solution to 079-578-2908 or all your clarity seeking questions on that particular number, grade 12. I'm repeating the number. So our WhatsApp number 079-578-2908. So now let's go back to our question. We are having a cereal box that has the shape of a rectangular prism. This is now a prism. Why? Because it's now a container. You can pour something into that particular box. On the previous question, we were talking to the flat surface where we were talking in area. So we were having a length and breadth. It's a 2-dimension, that one. And then in this case, we are having a container. If it's a container, it's a 3-dimensional problem because now you can pour it, either cylinder or a box or a rectangular prism. It depends on the type of the container. Then grade 12, we call this type of problem the 3-dimensional problems. And then now, this is the rectangular one. As you can see, the box is forming a rectangular shapes around it. And then the box has a volume of 480 cubic centimeters. You remember the units for the area is the square unit, centimeters squared or square meters. But with the container now, we talk volume, then it will be cubic units, okay? And then now it has a breadth of 4 centimeters as indicated there. And then the X centimeter for the length of the box, and the height of the centimeter is indicated just with H centimeters. And then you need to determine the height of this cereal box now in terms of X. So grade 12, remember, you always start from what is given to you. Start from the given information. So here we are given the volume, so we will rely on the volume formula from the given formula box there. So it states that volume is equal to length by breadth by H. And then now we are going to substitute now the volume 480, the breadth 4 centimeters, the length with X centimeter. H, we leave it like that because it is H of which we are looking for in terms of X. So now let's substitute. Volume is 480 cubic centimeters. We are ignoring the unit for now. And then the length is X as indicated and also given to us that the length is X centimeters. And then the breadth is 4 centimeters, given as 4 there. Also on the diagram, it's 4 centimeters. And then we have our height, of which is still H. And then from this step, grade 12 now, remember we are looking for H. We need to get rid of 4 and X there. So we are going to multiply the brackets out. 4 times X is 4X times H, it will be 4XH as indicated there. And then we divide both sides by 4X so that we are left with only H this side. Hence, on the left-hand side, we are having 480 over 4X for H there. So when we simplify this, we end up with H equal to 120 over X. We have divided by 4 into 408, of which give us this 120 on top there. So H will be equal to 120 over X. That is our height in terms of X. So the height here will be equal to 120 over X. Okay, now we have everything now in terms of one unknown, of which is X. To the next question, 3.2. This cereal box now, we are still using the same cereal box, of which we have calculated that this will be 120 over X, our height in terms of X. And then now with same dimensions now, grade 12, we need to show that the total surface area. Remember, when we talk area, we are talking a flat surface. When we talk a prism, it's a container. If you look at this box now, it's a prison because you can pour something inside that particular box. But when you talk total surface area now, we are talking a flat surface. That means you are going to cut the edges of this box and form a flat surface now. So now, when we cut this box, we end up with a surface like this one, of which when you check around the box, you will be having this parts here, of which is 4 parts, of which the front, the back, the left, and the right hand side of your box. This is the flat part. And then here we have the top and the bottom part of the box that is enclosing the box to form a container. So this is the box, that is the net diagram. Now we are flattening this box, now forming a flat diagram of that particular box. So you just cut the corners of the box and then form a flat surface like this one indicated here, in order to calculate the total surface area of that one. So now let's put now the dimensions of this. And then if you look at the front part here, the dimensions of this will be x by the height of 120 over x. That means the front and the back part will be taking what? Will be taking 120 over x together with the x side here. So this is the front, and then this one is the back part. So these are sharing the same dimensions, which is 120 throughout, okay? And then now the x part side and the x side there. So now for the left and right, we are taking this part here. So for that part of the box, we are still using the same height, but with the breadth of 4 there. So this one will still have 120 over x, but the breadth will be 4 now. So the left hand side and the right hand side, this side here, will be using 4 by 120 over x. So it's 4 by 120 over x. And then now we consider the top part now, that part and the below part here. The dimensions will be x by 4. Correct? X by 4. That means this will be x by 4 and the x by 4 there. So basically, grade 12, we now have a clarity that we will be having a flat surface like that one. So we can now start determining the total surface area. And then the formula, fortunate enough, will be given to you. So this is a closed serial box. Therefore, it will be having 2 length by breadth, 2 length by height, and 2 breadth by height. Okay. So that is the formula for that. And then let's substitute now. We are having 2 times x by 4. That means we are taking x by 4. So x by 4 is this shape here and that one. How many do you have? 2 of them. That is why we are saying 2x times 4 there. And then the next one is saying 2x by 120x. X by 120x, we are talking to this flat rectangle there. X by 120x is another one, is this one, of which is having the x by 120x side there. So that is why we are saying 2 of them. Continuing, we take the side now where we are having 2 of 4 times 120 by x. 4 by 120x, we are taking this 4 by 120x. This is 4 by 120x. Grade 12, can you see that we have covered all the areas now? Hence, we are having 2 times 4 by 120 over x there. Everything is now presented, okay? Now, we are going to remove the brackets now by multiplying throughout. 2 times x times 4, that will be 8x, and then 2 times x. Remember, this x will cancel that one. Then you will be left with 2 times 120, of which is giving you 240. For this one, we are having 2 times 4, which is 8. 8 times 120, which is 920, over x there. And then grade 12, if you compare this to this, the given total surface area, that is true, is 8x, 8x. 960 over x, 960 over x, plus 240 plus 240. That is exactly the same total surface area for our given box there. Activity number 3, we are still on the same given information. We are determining the value of x for which that total surface area that we have calculated is now minimum. If they say it is minimum, that means you need to differentiate, let it equal to 0, find the value of x. Same method, grade 12. Differentiate, let equal to 0, and solve for x. So we are going to take our total surface area formula that we have calculated above. Remember, this was 960 over x for this part here. So we have taken x up there to get a 960 x to the power minus 1, because you cannot differentiate with the x on the denominator there. And then now moving on, we are going to differentiate the total surface area in terms of x. So now the derivative of 8x will be 8, as you have that 8 then. And derivative of 240 will be 0, because 240 is a constant number. Derivative of a constant number is 0. Hence, you don't see any notation there. It's a 0. And then now minus 1 times 960 will be minus 960. Subtract 1 from the exponent will be a minus 2, as you see there. So this is the correct derivative of this total surface area in terms of x. We let it equal to 0. We have now noted this back to its fraction form, which is 960 over x squared. We are taking that x to the power minus 2 back to the denominator. And then we let it equal to 0 now, because we want to solve for x. And then next step, we are going to multiply throughout by the x squared on the denominator. So we end up with 8x squared. And then if you multiply this 960 over x squared multiplied by x squared, the x squared will cancel x squared. Hence, we have only 960 there. And then we are solving for x squared 12. We are going to transpose the 960 to the left, then it will be positive 960. Hence, we have 8x squared equal to 960 then. So next step, we will be dividing both sides by 8. Divide both sides by 8. Then when you divide 8x squared by 8, you end up with x squared. Divide 960 by 8, we end up with 120 there. And then this side will lose an exponent 2. This will gain it as plus minus the square root of 120. And then now, because we are talking to the length of a box, we will consider it being only the positive one. Hence, we are having only the positive solution there. We cannot say the length is minus 2, minus 3 centimeters. No, we only consider it to be a positive identity. Hence, we are taking the x equal to positive square root of 120 kilograms. So that is the value of the x side there, which is square root of 120. And then the h, remember, height is 120 over x. That means this will be 120 over the square root of 120 there. Right. So you can write this in simple set form, that is 2 square root of 30. You are also welcome to write that as to the nearest integer, because this will be 11 comma something. You can write this as 11 centimeters, grade 12. So you are also welcome. So that will be basically 11 centimeters approximately. So the x side will be 11, and then the height will be 120 divided by 11 there. This is another question. an open rectangular box now. This one is open. That means one side is not there. It's an open box, like your shoe box without the cover. It's an open box like that one. Has the following dimension. The length is 5x centimeters. The breadth is 9 minus 2x centimeters. The height is x centimeters. Show that the total surface area of the container can be expressed as total surface area minus 4x squared plus 63x. Okay, this is the box given to us, grade 12. So if you cut here, cut there, you'll end up with a net diagram like this one here. As you can see, this is the bottom part of your box. This is the left hand side of the box. This is the right. This is the front part, and then this is the back part of your box. So basically, this is the flat surface of the box now. Now we want to put these dimensions into the box. When you look at the bottom part here, it is having dimension 5x by 9 minus 2x. That will be 5x by 9 minus 2x. And then now the front part is this one here. We'll be having 5 by x. So this one front will be 5x by x. And then the same applies with that side at the back there. They take the same dimension. This is also 5x by x. So that will be 5x by x. And then now we look at the left and right. And then if you look at the right hand side, it's 9 minus 2x times x then. That will be the 9 minus 2x times x. 9 minus 2x times the x side there. The same applies with the left hand side one. Remember, this is 9 minus 2x multiplied by the x side of which is the same as that one. So this will be 9 minus 2x times the x side. So we have tried, grade 12, to put all the readings on the diagram. And then from here now, we want to calculate the total surface area. So if we look at our formula now, in this case, we have only 2 LH, 2 BH. For this one, we have only one. Why? Because the top part is open. So the bottom part, we are only going to have one part for this one. There's no matching part, which is the top part, because the container is open. And then now let's see at the formula. Select the formula from the box of the total surface area correctly. So as you can see, the first one is LB only without 2. But if it was closed, it will be 2 LB. We are now substituting. For the bottom part, we have 5x multiplied by 9 minus 2x as indicated there. And then now we are having 2 LH. That is 5x times x. 5x times x. How many do we have? 2 of them. 1, 2. That is why we say 2 of 5x times x. And then lastly, left and right, we have 9 minus 2x times x. 9 minus 2x times x. Hence, we have 2 of them. 9 minus 2x times x. 2 of them. And then now we continue grade 12. We are removing the brackets now, simplifying this. We have 5x times 9, which is 45x, minus 5x times minus 2, which is minus 10x squared. And then 2 times 5x, that is 10x times x, that is 10x squared. And then 2 times x here is 2x. 2x times 9, that is 18x, and then 2x times minus 2x, that is minus 4x squared. And then from this level now, grade 12, so we'll be looking at the like terms. As you can see, you have x squared and the x only there. So we are going to add like terms. So when we add 10x minus 10x will give us a 0. So we are left with minus 4x squared there. And then 45x plus 18x, it is giving us 63x. Therefore, grade 12, this is the correct total surface area for that particular open rectangular box. Moving on to the next question, we have our answer then. And then now activity 4, we are still on an open box. We want to determine the volume of the box in terms of x now. Remember, we have the volume from the total surface that we have calculated previously. In this case, we are determining the volume. So we are relying on this equation now in terms of x, okay? The volume will be LBH because it's a box, length by breadth by height. And then now we are going to substitute our length 5x, the breadth 9 minus 2x, and the height with an x from the given information there or from your diagram there. And then now after substituting, we are going to multiply everything. So that will be 5 times x, which is 5x squared. We still have to multiply this 5x squared into this bracket here. It will be 5x squared times 9, of which is 45x squared. 5x squared times minus 2x, it will be minus 10x cubed. As you can see, this is a cubic identity because it's a volume. Can you see a volume is having a relationship with your cubic function? It is x to the power 3 because it's a cubic identity. So this is the volume of the box in terms of x, grade 12. Activity 4, still on activity 4. We are now calculating the value of x. Calculate the value of x if for which the box will have a maximum volume. Maximum volume means derive the volume. If you want to solve for x, let it equal to 0 and solve for x. So let's maximize our volume. This is the volume we calculated on 4.2. And then we are deriving the volume in terms of x. It will be 2 times 45, of which is 90. And then we subtract 1 from the exponent. You are left with x to the power 1. 3 times minus 30, minus 10, sorry. That is minus 30. Subtract 1 from the exponent. It will be x to the power 2. So hence we have minus 30x squared as the derivative. Now we want to solve for x. Do you still remember the method? You let it equal to 0. Your derivative equals to 0 after differentiating. And then from here now, you can take out the common factor because you can see you have x and x squared on your values there. You can take out the common factor. So we are going to take 30x as being common. So now when you take 30x, now we are going to say 90x divided by 30x, it goes 3 times. Minus 30x squared divided by 30x, you end up with minus x. It's like 90x divided by 30x, of which is a common factor. X goes once there, and then 30 into 90, it goes 3 times. Hence we have 3 there, okay? And then now we also take the minus 30x squared, we divide it by 30, and then 30 goes once there. That is why we are having, that is 30x. The x will go once there. That is why we are having a minus x as our answer there for the second term. And then from here now, we are solving as though we are solving our equations as we are doing on question 1. So it will be 30x equal to 0, which is the same as x equal to 0 there. If you take 30x, you divide it, you equalize to 0, then you will be dividing by 30 both sides. Then x will just be at 0 there, okay? Hence we have that first x being equal to 0. For the second bracket, it's like you're taking 3 minus x equal to 0, then it will be x equal to 3. Hence, you have x equal to 3 centimeters for the second one. So when you look at the allocation of marks, it will be for the derivative, for letting the derivative equal to 0, and then now for factors and for your x values there. And then now, grade 12, there is no way that you can take x equal to 0 as the solution, because it will make this side to be a 0 there. 5 times 0 is 0. So we are discarding that one. X equal to 0 is not the solution. The only solution to maximize this volume will be x equals to a 3. Please check your answers and verify them before you conclude the solution. Now moving on to activity number 5. A manufacturer needs to make a cylindrical can. When you talk cylindrical, a cylinder is a can of Coke shape, a glass of water. Those are the cylindrical shapes, as you can see the one that is given to you there. And then now this cylindrical can hold 1,500 cubic centimeters. So inside the container, you can pour up to 1,500 cubic centimeters. That is the maximum that can be held by this container. Show that the height of the container can be expressed by h is equal to 1,500 over pi x squared. Now we are given the radius of this is equal to x centimeters and the height of the container being an h then. And then now if we check again, we are given 1,500 cubic centimeters. Therefore, you are given the volume of that particular container. You start from the given to unknown. Okay, so what is given to us is the volume. So we are going to use the formula of the volume, which is pi r squared h. Can you see that the volume is taking the area of the base? Our base is the circle here. That is why we are using pi r squared. And then now it will take the height of the container to be a volume. So a volume is the area of the base times height for all your prisms. Okay, your containers, grade 12. Area of a base times height. So in this case, it's V volume equal to pi r squared h. And then we will be substituting the given volume 1,500 for the volume. And then we have pi. For the radius from the diagram there is given as x. Then we substitute x for the radius. We end up with x squared times h. So now we are solving for h. We are going to divide both sides by pi x squared. And then now h will be 1,500 over pi x squared. That is the height in terms of pi x squared. Can you see, grade 12? This is exactly what is expected from you, because the answer was already given to you. Yours was to show, is this answer true? Okay. Moving on. 5.2. Determine an expression for the surface area of the can in terms of x now. So now if you look at the can, if we take this can and cut off here, because when we talk surface area, we need a flat area. So we cut also the bottom part. We will end up with the rectangular part in the middle as you are unfolding that, and then the circle on top and at the bottom of your can as indicated there. Okay, this is the cylindrical part of which will be presented by that rectangle. And then we are having the top and the bottom circles then, of which is indicated by those circles. Now we'll be having a flat surface. So now this will enable us to calculate the surface area of that particular can. And then now the total surface area of the can, no, that is not the correct formula, grade 12. And then now this one will be the length times breadth. Remember, we'll be having the length by breadth for this part here. And then if you look at this height, is part of one side of, because it's the height of that cane. And then this side here, it's when we cut off this part here, then it will be open and flat like that. And then this part, what do we call that? That is the circumference of your circle there. So now the formula for circumference, do you still remember that? That is 2 pi r. Okay? And then that means now, for this circle here, when we want to, for this side here, we are using that 2 pi r of the circumference. And then now that means it will be the area for this rectangular part here. Okay, and then now plus the 2 circles. Area of a circle is what, creatures? The area of a circle is pi r squared. So now we have analyzed the shape. Let's start now. We are saying the surface area, or the total surface area of this diagram, will be length by breadth for this part here, plus the 2 area of a circle, of which is pi r squared. 2 circles, pi r squared area of a circle. And then now what is the length of this? The length of this is 2 pi r. And then what is the base? The base is the height, because it's this part here. And then plus 2 pi r squared. And then this is the surface area in terms of x grade terms. And then now we are given the radius of this being x there. So we are going to substitute 2 pi, the radius is x. And then the height of the container plus 2, and then the pi, and then with the radius x there. And then we have calculated previously that the height of this container will be 1,500. over x. over pi x squared grade 12. Do you still remember? We calculated that as 1,500 over pi x squared. And then now we are taking this into this particular equation where we are going to have our formulas, then the substitution, and then we are going to substitute the value of our pi into that one. Okay, so we end up with the volume being, total surface area being okay, let's rely on this one. This is pi x squared, and then plus the 2 pi x, and then this will give us, x will cancel 1 x there. So we are having 2 pi times 1,005, that is 3,000 pi over x, that is remaining on the denominator, plus 2 pi x from that one. So that is the surface area for that particular cylindrical container. And then now let's move on to the next question. In this one, we have to determine the dimensions of the can now to 1 decimal place. That will minimize. If you are minimizing grade 12, that means you are differentiating. Okay, and then determine the dimensions of the can that will minimize the amount of material. You want to design a can now, and then you want to minimize the minimum material that you can use to manufacture that can. So when you minimize, that means you are still going to derive. This is our formula for the total surface area that we have calculated on the previous. So we are going to derive this total surface area in terms of x so that we can let it equal to 0, solve for x, and calculate the dimensions that will minimize this. So now when you derive this, it will be 2 times 2 pi, which is 4 pi. Subtract 1 from the exponent, this will be to the power 1. And the minus 1 times 3000 is minus 3000. You minus 1 from the exponent, it will be minus 2. And then the next step, grade 12, let it equal to 0 and solve for x. So we are going to multiply throughout by x squared on the denominator there so that you can get rid of that one. Then we end up with then, okay, we transpose this one to the left-hand side then. Then we end up with 3000 over x squared equal to 4x cubed. And then multiply by x squared both sides. Then we end up with 3000 equal to 4 pi x cubed. And then now divide by 4 pi both sides because we need this value of x here, which will give us this dimension here. And then now we divide by 4 pi. So x will be the cube root of 3000 over 4 pi. Okay, which is 6,2. So that is the value of the radius. Radius is 6,2 centimeters. And then remember now our height, we have calculated height as 1500 over pi x squared. Then we are going to substitute that value of x now into that x value of the height to get the actual height now. So we substitute 6.2 for x in that one. So we end up with the height of 12,4. So that means this container now, to minimize the material, you must make the height to be 12,4 and the radius of this to be 6,2. Remember, this x is the radius of that cane. From center to the circumference, it must be 6,2 centimeters. That will minimize. You'll use less material to make that particular cylinder. Can you see grade 12? This can assist you when you are in a factory where you have a material and then you need this calculation to assist you in terms of checking the minimum material that you may need. Okay. And then now we move on to activity number 6. An experiment is conducted. These types of problems now is the ones that we call it the rate of change. Where you are having diagrams, you call it optimization, because we will be maximizing the material, the volume, the total surface area. In this one, we are talking in relation to technical science, where we are having the rate of change with calculus in motion. So these are the types of questions we are talking to. They still fall under practical problems of differential calculus. Okay. And then now here given an experiment is conducted in which a temperature T in degrees Celsius varies with regards to time in seconds according to the formula. So we are given this formula and then we are working this capital T represent the temperature in degrees Celsius, and then the T is indicating time in seconds. Where our time is greater than and equal to 0 and less than equal to 10 minutes. That means we are ranging between 0 to 10 seconds of time, okay, for conducting the experiment. And then 6.1, it says write down the initial temperature. So initial temperature is at the beginning of the experiment before you can start with your experiment. That means your time will be 0 because you have not yet started with the experiment. So if you put 0 there and 0 here, that means we'll be having T at 0. This is your initial equation taken as it is from there. And then now we are substituting 0 for T because now we have not yet started with the experiment. Therefore, the time is 0. Then when you substitute 0 for T, 0, this will be 0, 0 then. So now the final answer will be T at 0. It is 37,50 degrees. So the initial temperature will be at 37,5 degrees Celsius before you start with your experiment. So grade 12, this will be 1 mark. Why? Because you can tell by putting 0 there, the answer will be that one. So we will be allocating mark for a final answer only. On the same given information, now 6.2, determine the rate of change. Do you still remember when we were starting with terminologies? We indicated that the rate of change is the derivative, okay? Now we are looking at the rate of change of temperature. That means we will be differentiating the temperature with respect to time when T is equal to 4. Determine the rate of change of temperature with respect to time when T is equal to 4. We are differentiating the temperature and then we check that differentiated temperature when T is equals to 4. That is what this statement means. So you need to understand the language around this grade 12. You must master this language. Otherwise, you won't be able to get correct answers. The minute you see rate of change, that means you must derive what is given to you. So now we are deriving this equation here. Our original equation, as you can see there, the notation is saying derivative of temperature in terms of time. And then now if it's a constant value, derivative is 0. If it is to the power 1, we take coefficient 7, as you can see there. And then if we differentiate this one, we say 2 times 0,5. So half of 2 is 1. Hence we see minus 1 then. And then we minus 1 from the exponent, then T will be T to the power 1. This is the correct derivative equation. When is at T equal to 4 now? We are using this T equal to 4. It will be a differentiated temperature at 4 seconds. Then we are substituting T with 4. Then it will be 7 minus 4. Then the temperature will be equal to 3 degrees Celsius per second. Okay. So that is the answer for that grade 12. That is how you answer that rate of change question. And then now moving on to 6.3. Determine the maximum temperature reached during this experiment. Maximum temperature. Can you see we are still involving the differentiation? But if you want to maximize, you differentiate, you let it equal to 0, you solve for T in this case, and substitute that maximized T into original to find the maximum temperature. So your starting point will be differentiating because you are maximizing. All right. And then you let it equals to 0, and then hence you have seen that you have substituted that with a 0, and then you solve for T. Then we are going to take T to the side to be positive T. Then T will be equal to 7, not degrees Celsius. This is time. It will be in seconds, grade 12. So it will take 7 seconds to maximize this temperature. And then now if you want the maximum temperature, then it will be at T equal to 7 seconds. Okay, the distance D in meters, that is another question 7, activity 7. The distance D is indicating a distance in meters. Remember, distance, they can use letter D or letter S, okay? It is both talking to the distance. Okay, the distance D in meters covered by a car in T seconds before reaching a certain point on a straight line road is given by the equation dt is equal to minus 0,5 t squared plus 20t. Determine the distance. There is no differentiating. There is no rate of change. There is no maximizing. There is no minimizing. That means they are talking to the original distance that is given to you. Determine the distance covered by the car in t equal to 10 seconds. So they say take 10, substitute into this and determine the distance. So now we understand what to do. We are taking our formula and then we are substituting t with 10. Wherever we have t, we have substituted that with 10. And then now the distance at 10 seconds will be 150 meters. That means that car will move and move. After 10 seconds, it will be at 150 meters. It will cover 150 meters. Okay, it's supposed to be 2 marks because it's one for substitution and one for the answer there. So I will allocate these 2 marks to be fair in our grade 12. 7.2, we are looking at the speed of the car when t is equal to 12 seconds now. When you talk the speed, do you still remember? A speed is the derivative of a distance. Okay? Speed is the derivative of a distance. That means we can't substitute 12 before deriving. We are looking at the speed, not the distance. So we need to derive the distance in order to get the speed. So we are deriving this distance formula. As you can see, derivative of distance in terms of t will be 2 times half, which is minus 1 t. And then this one, when you derive 20t, it will take the coefficient that is 20. And then now we are looking at the speed when t is 12. So we are going to substitute t with 12 there. That is it, grade 12. We have substituted t with 12, t12 there. So the distance that will be the speed of the car after 12 seconds, it will be moving at the speed of 8 meters per second. Okay. This is the toy car. Remember, it's not a real car, it's a toy car. And then now, next question 8. A factory producing light bulbs makes a daily profit, PX, that is the profit made by this factory, and this profit is in rands for the X number of bulbs. That means this factory is making light bulbs. So now they produce X number of light bulbs. So they represent the number of bulbs with the X and the profit thereof that they make in rands. And the formula to calculate the factory's daily profit is given by profit at X is equal to 0,8x squared minus 200x. Remember, X is the number of light bulbs produced per day, where X is greater than 0. Can you see grade 12? Why is X greater than 0? You cannot produce 0 number of bulbs every day. That is why this X must always be greater than 0. It must be a positive counting number, 1, 2, 3, 4, 5. It cannot be a negative number. You can't have a maybe minus 5 number of bulbs. No, they will always be positive counting numbers, natural numbers. Okay, 1, 2, 3. We cannot say 1.5 bulbs. No, those must be counting numbers that are positive. 1, 2, 3, 4, 5. And then now we need to determine the daily profit if 300 light bulbs are produced in one day. This factory now is making 300 bulbs per day. Now determine the profit that this factory will make in that particular day now if 300 bulbs are produced. That is what we need to calculate. So we'll take the original equation because we are just producing 300 bulbs. We want to see the profit that will come out of that 300 produced bulbs. So we are going to substitute where we have X. We will be substituting 300 bulbs. Hence, we have substituted every X with 300. And then into your calculator, grade 12, straight to the answer. How much will be the profit? The profit of 300 bulbs will be 12,000 per day. That is a great amount, grade 12. Can you see that factory is making a lot? Per day, if they can produce 300 bulbs, they will be able to make a profit of 12,000 per day. And then now let's look at the mark allocation. They say 1 mark, it is unfair. At least 2 marks will do. Will not give you a profit. how many possible bulbs that can you produce that will never give you a profit? Yes, bulbs will be produced, but they will never give you a profit. Sometimes when you think about this, it sounds like it is impossible to produce something and then it will never give you a profit. If you ask mathematical literacy learners, they can explain this to you thoroughly. So they have a calculation in their Mesli that is the break-even point, of which when you are having a certain you are selling something return, there's a point that below that point, if you are selling something that is below that point, it will never give you a profit. So it is very important that when you are selling, you calculate your break-even point. A break-even point is a point where whatever you are selling, it will start now giving you a profit. That means it is telling you that there is a possibility that you can produce or you can sell something and not get a profit until you reach that point of break-even. It is only then that you can have a profit. Sometimes you might give up thinking that you will never get a profit, but when you continue, persist, there's a point where you will have a profit. So this type of a question is referring to such question where you are producing, but you will never get a profit. Okay, let's see now how many bulbs will give us that zero profit now. So now we take our original profit equation, and then now the profit now is zero. We want to check now for how many bulbs can we produce where we are not going to get a profit. Our profit will be zero now. Can you see now you have x being common then? We are going to take out the common factor, x, and then when you take x out here, it will be 0.8 x squared divided by x common. X will cancel, 1x will be left with 0.8x. Hence, we have that in the bracket. The next one, we have 200 x divided by x common. X will goes once there, you'll be left with 200. Hence, we have minus 200 in the bracket. So the first x here will be equal to 0 as the solution, or the 0.8x here will be equal to 200 because you'll be taking 0.8x minus 200 equal to 0. So it's like this x equal to 0 and your bracket equal to 0. So we transpose minus 200 to that side, hence we have 0.8x equal to 200. So for this part here, we are going to divide both sides by 0.8. So we will be left with x is equal to 250 bulbs. That means grade 12, the first solution is that when you don't produce any bulbs, you'll get zero profit. But we are cancelling this as being not the solution because they said you must produce bulbs every day. The production of bulb must be greater than 0. Remember, x is the number of bulbs. It must be greater than 0. So there is no way that we can get 0 bulbs. So now our final solution will be when you produce 250 bulbs, grade 12, you will never have a profit. In order to have a profit, you must produce something greater than 250. It is only then that you can get a profit. So that is how you calculate when you start selling something and checking whether you will get a profit or not. This calculation will assist you to give you the minimum that you can sell per day in order to get a profit. So this is what we are using for identifying such cases, grade 12. I hope this is clear. It will assist you when you want to start your small business, grade 12. There are cases where you can sell your sweets and then you will never get a profit. You must be able to calculate and get a clarity. How many sweets must you sell per day in order to be able to produce a profit? This is very important if you have a business, this type of calculations. And then now we are still on 8.3. The rate of change of the daily profit with respect to the number of bulbs if 200 is produced. Rate of change, that means we are differentiating. And then we have 200 number of bulbs. That means X will be 200 after differentiating your profit. So we have differentiated our formula there. We have P at X, derivative in terms of X of profit, and then this will be 2 times 0,8, of which is 1,6, and then minus 1 to the exponent, it will be X, and then this one is to the power 1, we take minus 200 as the derivative. So we are now substituting X with the 200. As you can see, we have substituted X with 200, and then this is giving us how much, grade 12? At the rate of change 200 bulbs, then it will be 120. The rate of profit, it will, at 200 bulbs, will be 120 grade 12s. And then now this is our preview of the next lesson, grade 12s. We will be having just in time. Our date is 19 March 2025. Time is 2 o'clock to 3:30. And then we will be looking at the sketching of the cubic function. Thank you, grade 12. This lesson was brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. See you next week. Thank you.